In this video, we will practice finding the derivative of logarithmic and exponential functions. Let's start with logarithmic functions, and here's the key to it all. If we have y equals natural log x, the derivative is y prime equals 1 over x. This is an important fact that you need to memorize. It will show up throughout the rest of AP Calculus. So let's apply it to some problems. Looking at problem number 42, I need you to see that we will need the chain rule. This is an outer function and an inner function. I'm going to colorize it a little bit to make it more obvious. So as we begin to write the derivative, f prime of, So as you write the derivative f prime of x, you should be thinking we need to first take the derivative of the outer function. So if I write 1 over x minus 1, that's the derivative of the outer function. But then I need to multiply by the derivative of this inner function. But, well, the derivative of x minus 1 is just 1, so in this case that didn't really do anything. It'll be a little bit more interesting on future problems. But this is the answer to number 42. Moving on. Okay, let me colorize this one more time. So we have h prime equals, the derivative of natural log is 1 over x. So I'm going to write 1 over 2x squared plus 1. That's the derivative of the outer function. Now I need to multiply by the derivative of the inner function, which will be 4x, just applying the power rule. Now I could multiply this by the numerator. I could put the 4x in the numerator, and this is actually the most common way of writing the derivative. So usually you will see 4x over 2x squared plus 1. So this is how you should expect to see the derivative. On number 46, we will use the product rule because we can view this as x squared times the natural log of x. So the way the product rule works, first you take the derivative of the first factor, so that'll be 2x, and you leave the second factor alone. So that's natural log x. And then you put a plus. And then you sort of go through this again. But this time you leave the first factor the way it is, and you multiply by the derivative of the second factor. We just learned that the derivative of natural log x is 1 over x. So this is the answer, and if this were a free response question on the AP exam, you could just leave your answer like this. But what if it's multiple choice? You might want to simplify a little bit. So here's another version. Do you see what I did here? The x in the denominator canceled out one of these x's. I could also factor an x outside of parentheses, but yeah, I'm sure you can picture that on your own. Let's move on to number 48. Wow, I think we have a double chain rule here. Let's take this derivative in stages. So y prime equals, first we take the derivative of the outer function. So the derivative of natural log is 1 over x. So I will put 1 over the square root of x squared minus 4. But then I need to multiply by the derivative of the inner function. But wait, the inner function is a function inside of a function as well. So here comes another chain rule. I need to take the derivative of the inner part, but I need to do the purple part first and then multiply by the derivative of the green part. So you can see I rewrote the square root as the 1/2 power so that I can do the power rule. So I'm taking the derivative of the inner part, but first I do the purple. So I do the 1/2 in the front. I subtract 1 from the exponent, so that will leave me with negative 1/2. I leave the inside part the way it is, but then I multiply by the derivative of the inside part of the purple, and that will be 2x. So this is a valid expression for the derivative. So you could write your answer just like this and leave it like this. However, if this were a multiple choice question, it would not be left like this, so I need to show you how to simplify this answer. First of all, we have this 2 times the 1/2. So those are going to cancel each other out. So those are gone, forget about that. The x is going to end up in the numerator, so I'm going to go ahead and write that down. So I have y prime is equal to, and I've got my x sitting there. And then here comes this factor. I've got x squared minus 4 to the negative 1/2 power. And in the denominator, I'm going to go ahead and also write this as a 1/2 power to make it match what's going on in the numerator. So I have x squared minus 4 to the 1/2 power. Now, side lesson, you know that if I have n to the 6th power divided by n to the 3rd power, is this going to be n squared because 6 divided by 3? Nah. You know this will be n to the 3rd power because it's 6 minus 3. So when we divide, we subtract exponents. So that's what is going to happen here. We need to do negative 1/2 minus 1/2. Just think about that for a second though. If I have negative 1/2 minus 1/2, that's going to be negative 1 whole. Okay, so just watch out for that to happen. So on my next step, I'm going to have y prime is equal to x times x squared minus 4 to the negative 1 power. Okay, and then because of the negative exponent, I could drop this factor down to the denominator. Couldn't talk for a quick second there. So that will leave me with x squared minus 4. So if this were a multiple choice question, this is probably how it would appear among your options. So make sure you know how to simplify things like this. Number 54, we could either do this problem using the quotient rule or we could avoid using the quotient rule. Some people try to avoid it. I like the quotient rule. If you know the quotient rule, it's pretty easy. But if you're a quotient rule hater, here's what you would do. First, you would rewrite this as you would bring the t up to the numerator. So you would have, I think I'll put it on this side. You would have t to the negative 1 power times natural log t. Okay, so we rewrote it. And then you would use the product rule. So you would go h prime equals, you take the derivative of the first factor, so by the power rule, that negative 1 goes in the front, and then you reduce this by 1, so that's negative 2. You leave the second factor alone, so natural log t. You put a plus. Second time through, you leave the first factor alone, so t to the negative 1 power, and then you multiply by the derivative of the second factor. Derivative of natural log t is 1 over t. So this is the answer. We would have some manipulation to do to kind of simplify this down. I'm not going to do that because now I'm going to go back and do the quotient rule. Listen to this quotient rule poem. Low d high, less high d low. Draw the line and down below, the bottom squared will go. Love it. Okay, so when I say d high, I'm talking about the derivative of the top. D low is the derivative of the bottom. So I'm going to say that poem again as I work it out. So h prime at t equals low d high. So low means just write the bottom part as is. And then d high means the derivative of the top part. So that would be 1 over t. So that's low d high. Less, subtraction, high d low. So high means just write the top part the way it is. And then d low means the derivative of the bottom part, but that would just be 1, which I didn't really need to put. Draw the line, and down below, the bottom squared will go. So to me, doing the quotient rule automatically simplifies more of the problem. There's more to simplify when you turn this into a product rule first. So I like the quotient rule. Plus I get to say the poem, which is fun. And then these t's cancel each other out, so this would just be 1. So just very quickly, you will have 1 minus natural log t over t squared. So know your quotient rule and use your quotient rule. It's good. Don't be scared of the quotient rule. The quotient rule is your friend. Number 56 looks really interesting because we have a natural log inside of a natural log. Clearly, we are going to have to do the chain rule. So let me illustrate this for you. We have the outer function, which is this natural log. We're going to take the derivative of the outer function first. So if I do y prime, the derivative of natural log is 1 over x. So I'm going to get 1 over parentheses. So that's the derivative of this outer function. But then, there's something inside the parentheses. The natural log x is in there. So because there's something extra inside the parentheses, then it's the chain rule, and we have to multiply by the derivative of the stuff inside. But again, the derivative of natural log x is 1 over x. So that's what we multiply by. We could clean this up a tiny bit by writing 1 over x natural log x. So that's the answer. For number 66, we need to find an equation of the tangent line to the graph of f at the given point. Whenever they ask me to find the equation of a line, I use point slope form. So that means I need two things. I need a point and I need the slope. One cool thing is they already gave me a point, the point of tangency. So really all I need is the slope. Of course, I will find the slope by finding the derivative, which will give me a formula which will tell me the slope at any point, including this one. But we're going to need the chain rule. So let me illustrate the chain rule for you. This has an outer function, which is natural log. Okay, that's the outer function. So we're going to start by taking the derivative of the outer function, and that would be 1 over parentheses. But then, of course, there was some stuff inside the natural log. It was x to the 3/2 power. So I'm going to go ahead and fill that in. But because there was stuff inside the parentheses, we need to multiply by the derivative of that. So I am going to do the power rule and move the 3/2 to the front. And then I need to reduce this exponent by 1. So in my mind, I'm thinking minus 2/2. So that should be 1/2. So I'm going to have x to the 1/2 power. Okay, I just realized that I did that the long way, and I almost erased that part of the video and just did it the short way, but I decided to leave it in so you could see that this is the long way, and you can compare it to what I'm going to show you now. A quick side lesson about logarithms. Remember that if you have, well, let me stick to natural log. If you have the log of something that has an exponent, so let's see the log of x to the 5th power, you're allowed to move that power to the front without changing the value of the expression. So this would be the same thing as 5 natural log x, right? These are just the same. That's a property of logarithms. But if I do that on this problem before I take the derivative, then I don't have to do the chain rule at all. So the original function could be rewritten by putting the 3 halves in the front. So I could put the 3 over 2 here, and then I would just have natural log x. So now if I wanted to take the derivative, all right, I can just leave the constant in the front alone, just move past that, and then take the derivative of natural log, and that's just the rule of 1 over x. Obviously, this is a lot simpler than the garbage that we did the first time, so let's use our logarithm properties. Anyway, we are on a mission to find the slope. Specifically, we need to find the slope at the point 1 comma 0, which really means we need to find the slope at an x value of 1. Well, if I plug 1 in for x, that's just going to be 1. So I'm really going to get 3 over 2. So that's the slope. So I now have a slope of 3 over 2. And remember, in order to write the tangent line equation, all we needed was a point and the slope, and now we've got it, because we're going to just do point slope form. So y minus y1, so that's y minus 0, is equal to the slope times x minus x1. So there you go. This is the equation of the tangent line. Let's do the same thing again for number 70. We need to find the equation of the tangent line at the point 1 comma 0. Before we take the derivative of f of x, let's definitely use our logarithm rules and put this little exponent in the front. So we have this. To find the derivative, we will use the product rule. So the first time through, we're going to take the derivative of the first factor and leave the second factor alone. So the derivative of sine x 2x. The derivative of sine is cosine. By the way, this is going to be the chain rule because we have a function inside of this function. Starting with the outer function of sine, the derivative will be cosine. Okay, I think I'll change colors to illustrate that we have this inner function. And when you have an inner function, you need to go ahead and multiply by the derivative of that immediately. So that's going to just be 2. So there I have taken the derivative of the first factor. So back to the product rule. You take the derivative of the first factor and you leave the second factor alone. So here's my 2 natural log x. So that's my first pass through the product rule. But then you put a plus and you go through again. But this next time through, you take the derivative of the second factor and you leave the first factor alone. So I'm going to leave sine 2x alone, but then you multiply by the derivative of this. When there's a constant in the front, that just sits there. And then the derivative of natural log is 1 over x. That's the big thing that we just learned today. So this long expression is the derivative of f of x. I simplified a tiny bit here. I did the 2 times 2 And that's where this 4 came from, and I wrote the 2 times 1 over x as 2 over x. That's all I did. Anyway, our goal is to find the slope at this point. In other words, the slope at x equals 1. So I need to find f prime at 1, which means I'm going to plug in 1 for all of these x's. So it looks like this. And at first I was thinking, wow, this is the longest slope I've ever seen. Except I realized one thing. The natural log of 1. This has a value of 0, which is going to wind up wiping out this entire part of the equation. Here's a quick side lesson just in case you needed it. Here's how logarithms work. If I have log base 2 of 8, this is asking the question, what power turns 2 into 8? And the answer is 3, because 2 to the third power is 8. So this would be the value of log base 2 of 8. We also know that natural log just means that it is log base e. So natural log 1 is log base e of 1. So this is asking the question, what power turns e into a 1? And the answer is 0, because e to the 0 power is 1. Anything to the 0 power is going to be 1. So that's why the natural log of 1 is 0. Anyway, so we just have this part left. I'm going to put the 2 in the front, so we will get 2 sine 2. Remember, the derivative is the slope at this particular point. So the slope, even though it's a little bit weird that it's not just a simple number, the slope is 2 sine 2. So we can still go ahead and write the tangent equation, even though the slope has a sign in it. We still will write y minus y, which is 0, is equal to the slope, which is 2 sine 2, times x minus x, which is x minus 1. And this is still good. This is the equation of the tangent line at the point 1, 0. At the beginning of this video, I said we would be doing derivatives of logarithmic and exponential functions, but I think this video is long enough. So watch the next video to see how to take the derivative of exponential functions.